with the refraction of length, and our learning objectives is calculation on refraction of length using the length formula. Now, in the last class, I talked about length formula and I talked about magnification. Now, today we are going to look at an example to lay emphasis on calculation on length and the use of length formula. Alright, look at the example of the board. You have an object 2.5 centimeter long is viewed through a converging lens of focal length 5.0 centimeter. Held close to the eyes, a magnified image of the object is formed. Remember what I said about magnified image. 30.0 centimeter from the lens. I will come again. A magnified image of the object is formed 30.0 centimeter from the lens. That means this 30.0 from the lens is the image distance, but the image formed is a magnified image. Alright, so the question is calculate the distance of the object from the lens. Remember, this 2.5 centimeter is the object's height. Alright, so what do we do? Now, first of all, let's start with the diagram. Alright, now in the diagram on the board, you have a converging lens. Remember, a converging lens is a convex lens, and you are told that an object 2.5 centimeter long. So that means the object is 2.5 centimeter. That is the height of the object. Alright, and you are told that the focal length is 5.0 centimeter. Now the F focal length is 5.0 centimeter and it should be positive. Why? Because it is a converging lens, and a converging lens always produces a real image. So the focal length should be positive. Now you are told that a magnified image of the object is formed. That means the image is a magnified image. Alright, so the image will be bigger than the object, but we don't know the height yet, we don't know the size rather. Now, they said a magnified image of the object is formed 30 centimeter from the lens. That means from the lens, the image is 30 centimeter. So this is your V. But we're not given our U, alright, which is the object's distance. Your U is unknown. So the first question said the distance of the object from the lens. That is your U now. So now to calculate your U, you use the length formula, which is 1 all over F is equals to 1 all over V plus 1 all over U. Since you are looking for U, you make use of the formula. You take this to this side, it becomes 1 all over U is equals to 1 all over F minus 1 all over V. So you have 1 all over your F is equal to 5 centimeters. So you have 5 minus your V, which is 30, you have 30. The LCM here will be equals to, the LCM of that will be 30, the LCM of 5 and 30 is 30. So you say 30 going 5 will give you 6 times, 6 times 1 is 6 minus 30 going 30 is 1, 1 times 1 is 1. So you have 5 all over 30. So you have 5 going here, 1, 5 going here, 6. So you have 1 all over U is equal to 1 all over 6. So since you have this, don't leave your answer like this, it will be very wrong, okay? So you do the inverse, alright? When you do the inverse, you have 1 all over, you have rather, so therefore, your U becomes equal to 6 centimeter. That is your object's distance. Alright, we're not done. Now, we've gotten the object distance. Now, the question B says the size of the image. Now, to get the size of the image, we use H all over H, that is image height all over object height, is equals to image distance all over image distance. You make this H subject of the formula. Alright? You cross multiply, this becomes H times U equals to H times V. You divided by U, divided by U. This cancels. So therefore your H becomes equal to H times V all over U. So you put everything into all the parameters into the formula. So your H, which is the object height, the object height from here is 2.5, okay, times, this is the image distance, which is 30, all over the object distance you got, which is 6 now. So 6 go here 1, 6 go here, will give you 5 times. So 2.5 times 5 will give you a H as 12.5 centimeters. So, like the question said, this is the image distance height and you are told that the image is a magnified image. So that is why we have an image of 12.5 which is larger than the object because it is magnified. Alright, so from this place, your power of lens, power P, okay, is equals to 1 all over, very simple, it is a very simple calculation. It becomes 1 all over the focal length in meters. It must be in meters. So you now ask yourself, but the focal length we are given is in centimeters, so you convert it to meter by saying your F is equals to, you divide that 5 by 100, that will give you 0.05 meters. So therefore your P becomes equals to 1 all over 0.05. So that will give you, I think that will give you 20. Alright, so that becomes 20 diopter. Diopter is the unit for power of a lens. Alright, so that is all. So you've seen how to calculate the distance of the object, the size of image, and then you've seen how to calculate the power of lens. So I hope this video will help you a lot in understanding the calculation on lens. And I know if you're having a question or you need clarity on something, please, you can hit me up on WhatsApp group. So the notes for this topic has been uploaded on the Golden Line School online portal. So you go there, you download the notes, you watch this video, and if you have a question, you send it to me on WhatsApp. Thank you very much for listening.